Next presenter is a well-known expert in decision management area, and recently, I believe last year, Silvie published one of the first serious book about XAI, explanational AI, and she will talk about this, but I also expect she will do what she always does. She brings a real world view from trenches of decision management and always real problems that she faced during her own development. Like last year, everybody enjoyed her presentation about airlines. And let's see what we will hear today. Silvie? We cannot hear you. Unmute yourself.
Yeah, here we go. Is that fine?
Yes.
Okay, great. Welcome. Thank you, Jacob. Yeah, a year ago, someone asked me when rule-based systems would be replaced by artificial intelligence systems. And my immediate response was never. However, this view was not shared by my beholder. According to some, AI is smarter, easier to develop without any maintenance cost and the future. Oh, I realized that not everyone knows about the benefits of combining rule-based with machine learning. In this session, I will share my experience with rule-based decision support systems and machine learning while making a case for explainable artificial intelligence. And as Jacob said, this presentation is based on my book available at Amazon with the same name. Now, AI is a technology trend and it's referencing development to automate or optimize tasks that traditionally have required human intelligence. This is a very broad definition, and to understand it really, you need to know what human intelligence is, which is, as you may understand, a research topic on its own. But since this definition is widely used, we stick to it. You may have heard some related terms such as machine learning and algorithms. Experts in the industry prefer to nuance the broad definition of AI by distinguishing different technologies that support it. But for this session, I will just use the term AI to reference all techniques popular today under this name. According to Microsoft, what we see here is a chair and a table and a wall indoor. But actually, we see the analytical engine designed by Charles Babbage in 1937 and built in 1907 in a museum in London. He worked closely together with Lady Lovelace, generally considered to be the first programmer because she supplemented the article of Babbage with notes about the capabilities of the machine when programmed using a logical language. She also saw the limitations and stated that the machine will not have the power to originate anything new. And this is a very long time ago. What an insight. Now, increased AI investments are reflected in this Gartner hype cycle for 2018. Artificial intelligence is moving towards the peak. I'm sure that one of you is involved in a project today that includes AI technology. AI is used in finance to predict share values, assess mortgages and insurance risk, detect fraudulent transactions, to name just a few applications in the core business processes. AI is also used to optimize other processes like planning, marketing, sales in diverse industries such as retail, supply chain management and transport. And did you know that startups in AI raise more money and that within the next decade, every individual is expected to interact with AI-based technology on a daily basis. So AI is everywhere and it is an important development. Now, this is already the third AI wave. And it's driven by more data and faster machines, while using technology that was already available or developed during the first AI wave. The second AI wave in the 90s focused on expert systems. There was no data, so we had to find another way to teach a computer a complex task. Business experts would express their knowledge in a set of rules that could be used by computers to support human decision makers. I graduated in artificial intelligence during this second AI wave and have been creating decision support systems for many industries and processes in my professional life. Now, wait a minute, actually that's not true. I did not create these systems because I'm not an expert in all these different industries. My challenge has always been to make the system in such a way that the industry experts really feel involved and responsible for the knowledge that is used by these systems and are able to keep the knowledge up to date. Rule-based systems have limitations because it is, for example, impossible in a lifetime to create rules to interpret all traffic signs or to detect any fraud or mimic DALI. Just to give you a fun example of the power of artificial intelligence, let's go to the DALI Museum. There, the deceased artist DALI is talking to you, explaining about his life and making selfies with visitors as if he is still alive. It's fun, people like it, and the learning experience in the museum has more impact. Artificial intelligence made all this possible, is what the promoting video tells us. And yes, in some sense that is true. A neural network is trained on old videos and pictures of DALI. The resulting model found patterns in his mimics. This is AI technology used for fun. Now let me give you a small example of how such a neural network actually works and what it does. Artificial neural networks are biologically inspired. We have neurons in our brains, but we learned in the past 40 years that they behave very different than artificial neural networks. To start explaining a neural network, we go back to basic mathematics. Solving an equation with one free variable is easy and what we all learned at school. But if you have two variables, in this case x and y, you need at least two equations to figure out what those variables are. And if you have more variables, things get more complicated. If you do this for many variables, what you can do is have a trial and error strategy and try to reduce the error with every iteration. And this is actually what a neural network does. A neural network consists of nodes and a simple formula by input, intermediate and output layers that are interrelated. Now the Hello World example of a neural network is recognizing the numbers in a 64-pixel grid. Each pixel is represented by an input neuron being on or off. And for each outcome there is an output node, 1 to 9. When an input node is activated, the path from the input node to the correct outcome will be reinforced. The idea is that the intermediate nodes will represent some common features, for example a horizontal line, and connect it to likely results, in this case the 2 and the 4 who share this specific pattern. Now adding more layers has proven this technology to get better results. But in the end, the resulting system can't do anything else than guessing the number represented in a pixel grid. And this is why our best learning machines don't actually think. And if you want to hear the story of Garry Kasparov being, having to deal with these machines, I have a reference for you here. A more serious example in finance is the detection of fraudulent transactions. It will use the same technology and looks for patterns in past transactions to flag an alarm on new transactions. This alarm will trigger people to look into it and potentially close an account. But the regulator monitors all these actions and mandates that these decisions are well motivated. And this is AI technology used for the good, unless you are a fraud. Now, the same technology can be used with good intentions but undesired results. The most cited example is Google's algorithm to help them selecting new hires. The result turned out to be highly gender biased towards men. That was not the intention. And the Google engineers, they are not stupid. They thought about this risk in advance and they deleted the gender from the dataset. But the model picked up the hobbies in the CVs, such as cheerleader. So the biases of our past selections are reflected in the historic data. A neural network is just a mathematical function recognizing patterns in data. Last year, some concerns about AI applications have been raised. AI is said to be biased. Governments raise concerns about the ethical consequences of AI, and regulators require more transparency. How do you feel about this? Now, at the same time, we know that human decision-making is flawed as well. Who wants to admit that his voting behavior is based on someone's looks? Psychological research, for example by the famous Nobel Prize winner Kahneman, proves that it is. What should we do? All my life I have been promoting transparency in the making of rule-based systems. But to my surprise, it seems to be acceptable that we don't know exactly what AI algorithms do, even if they influence our life and safety. Of course, it should not be acceptable. We need AI that is explainable, and this is what XAI stands for. In the remainder of this short session, I will briefly discuss 5 reasons why XAI solutions are more successful than an Oracle based on AI or any black box IT system. Decision support systems that explain themselves have a better return on investment. Why? Because explanations indicate when a solution needs to be changed or is outdated. Remember that every AI system in the end is also an IT system. And remember that the track record of IT is not that good. One cause is the collaboration model in many organizations between IT and business. In the last session, Jan and Larry discussed it. Intended complexity in COBOL code. This is exactly what I mean. AI being presented as a magical, complex black box solution will reinforce the failures that already exist. Here are the numbers. More than half of the IT projects are challenged or fail. The general issue that people overestimate their ability to evolve a system simultaneously with the business environment. And at the same time, organizations overestimate their IT skills. AI will not change this, and black box AI will make it worse. And we've already seen huge investments by organizations in AI that did not result in the expected outcomes. Second reason, providing explanations will increase the trust and confidence in your organization because the decisions are credible to the customer and your company can answer to regulators. To do this, your strategic and operational levels need to be very well aligned. This is especially important for the financial industry, who are held to higher standards and continuously monitored. Covering risks with liquidity has been a strategy over the past decades to handle risk in this sector. But this is changing. And I spoke to the Dutch financial regulator, and they even suggested in their latest report that operational controls may become more important than liquidity. And these operational controls will include ways to explain why your decisions are made the way they are. Decisions with explanations will also enhance the decisions because the explanations show biases and help to include missing common sense knowledge. This is important because a machine-learned predictive model always gives an answer, even if it doesn't make sense. The AI model presented with a foil, a fake image, makes the wrong decision. When he sees a cat in front of a doghouse, he concludes that it is a dog. And when he sees a dog playing with a ball, he concludes that it is a cat. And at the large airport, we forecast the number of expected passengers using historic data and machine learning techniques. Now, to use this model in exceptional situations, such as a holiday, common knowledge needs to be part of the explanation. And in COVID-19, these models turned out to be wordless, and we are back to the old approach based on heuristics. Another reason to do XAI is that it is feasible. There is technology to help you, but if you don't ask for it, you don't get it. I developed a 6-step method to help you do it successfully based on proven engineering practices. And for the sake of time, I will zoom in 3 of these 6 steps. One of the steps is about semantics. Businesses that can state clearly who they target and what it means to be successful are likelier to be efficient, effective, and successful in general, and also in the application of AI and decision support system. So AI innovations not only need data, they also need well-defined abstract concepts like genre and assessment, and understand the relationship between these concepts. Of course, I recommend to make a concept model. Another step is about understanding the task at hand that you want to support. I always recommend my customers making a decision model that shows how a decision, phrased as a question, relates to other decisions, data, and regulators. This opens the conversation and discussion in an organization and will lead to better understood and defined concepts. The most interesting step is to generate the actual explanation, and a good explanation. Now, I learned that a good explanation is more than the most distinguishable feature or a list of the complete rule chain, which is way too complex, by the way. One thing you should understand from the research is that an explanation does not need to be complete. Instead, it should be believable, relevant, distinguish the solution from alternatives, and be simple. As a consequence, you will need a separate model that generates an explanation and understands the user. Perhaps you even need different explanation models for different types of users. Now, AI technology differs in their learning capacity, their learning performance, and their explainability. So you should consider explainability when selecting your technology. Rules and decision trees are much easier to generate explanations. So that's a benefit. I graduated 20 years ago on a using a machine learned model, and then I used a machine learned model to generate a decision tree, which was used to generate explanations. So I believe that the combination of machine learning and rule-based is needed to support explainable artificial intelligence. Now, the research on explainable artificial intelligence falls into 3 categories. One is to use explainability as one of the optimization criteria for a model. But I think this is difficult because you don't know exactly what explainability means for your end user. Another is to improve the techniques that are better explainable to improve their performance. And finally, the one is to use techniques that generate explanations. There are some results in this area that focus on feature analysis. However, in general, many of the efforts focus on explaining the whole model instead of explaining one specific decision. And actually, I believe and I hope that the technology of, for example, Larry with language processing will at some point in time help finding a solution to explain a specific decision for a specific user. Anyway, when I dived into this topic, it concerned me as well. Are we in a catch-22? To avoid biases in decision making, we use explanations that take into account people's biases when valuing a decision. The explanation may even be incomplete, and the model may not be more accurate than an expert's judgment. I'm a little troubled by this counterintuitive conclusion. And what troubles me most is that we are asking engineers to understand and be aware of the impact that their solutions may have on people's lives. Anyway, the last argument I present here for XAI is that you want to be prepared for the increased demand for transparency from your customers and also from governments who are concerned about the effect of AI on fundamental rights of our democratic society. The European Commission concluded that these fundamental rights are at stake. For example, I named three things here. Freedom of choice is limited when you only see recommended products. Your access to information is limited when your own opinion is echoed in social media. And equality of opportunity is limited when we use biased data to train algorithms. The European Union created a report about trustworthy AI and is preparing legislation to require the right for a human eye and motivation for each life-changing decision. So, it is inevitable that machines sometimes suggest crazy things. Therefore, we need explanations. Without an explanation, their predictions can't be used for decision making. The advice is to have a human in the loop. I hope that I convinced you that explainable systems just make more sense and that the combination of rule-based and data-based artificial intelligence is the best way forward. Well, more tips and use cases on the approach and technology are discussed in the book with the same title. Thank you very much for your time, and I look forward to your questions, and I hope you have even more questions when using Slack instead of being together in one room.
Okay. Thank you, Silvie. We have a starting question from Jan Purchase about your view on the relative merits of post hoc generation of explanation of machine learning as opposed to producing inherently interpretable models.
I think the post hoc approach is more viable because then you can distinguish between the different kinds of users. As I showed, the explanation also needs to confirm to the existing beliefs of the user. And without having a model of the user, you will not be able to generate a good explanation. So assuming that you have different kinds of user types, it's better to have an ad hoc explanation. Also, if you go for an after the fact explanation, sorry, not ad hoc, after the fact explanation. Also, it's you can just use the most performing model in your machine learning if you do that. Does that answer your question?
I think Jan can come back with a follow-up if not, but
Okay.
Denis had a question about if you build a second model to explain the first one, how do you guarantee that the second model is sound and complete with respect to the first model?
This is a great concern. And that's what I said. Are we in a catch-22 here? Are we introducing another risk? Well, and is it worth the cost? I think it's worth it. But yes, definitely, it adds pressure on engineers, on testers, etc., etc. Definitely.
Okay. Bob Moore had a question about, or maybe more of a comment about it. Seems that there are two extremes of decisions some that where we can explain the decision, and others where an explanation is probably not possible, like image recognition. Do you agree with that, or do you have any comments on that?
Well, I have comments. Many people said to me, well, that's all nice explainability, but actually it's not needed for every decision, because some things it's just very difficult. And but then I've been thinking about it and looking at all the examples, and my conclusion is that it's better for all decisions to have an explanation, and also for image recognition. So what you can do for image recognition is when an algorithm looks at an image and says, okay, this is a dog, that the algorithm can indicate which parts of the image were most contributed most to the conclusion. And then what you expect is that the most contributing parts of the image will be like the nose and the ears and those kind of features, instead of the background being in the woods, or having a dog play around it. And well, if you do that analysis, we also saw that some of the algorithms that are in use, well, look at the wrong features and actually did not learn generic knowledge, but are biased.
And so James Taylor suggests that modeling the decision first and then integrating the artificial intelligence and machine learning, this would tell you what kind of explanation you need. What do you think about that?
Yes, I think that's a very good suggestion. And actually, if you look at the method that I propose, you will see that that idea is in the method.
Yes, and Carol Ann actually jumped in in a response to James and said that many times the model is created ahead of time, you know, with things like a credit score and so on.
Yeah.
So there very insightful comment from Rolando saying that this is about machine learning and human thinking, not or. Like, we really have to look at how we're combining both of these things to do this most effectively.
Yeah.
Okay, Jacob, do you have any particular comments you want to jump in with? I know that you always like to kind of have some comments as well.
I just wonder, based on this catch-22 discussion, what do you think we will see in the future? Self-explanatory systems in decision models, or it always should be two systems, or?
Well, from an engineering perspective, it is really much better if the systems are self-explainable. But I realize, given the research, that will, well, most of the time not be the case. And then I think it's better to have at least an extra model that generates the explanation.
Okay, we have a number of sort of discussions going on over in the Slack channel. Not really questions per se, but definitely if you'd like to continue those discussions, Silvie, I'm sure you'll hop in afterwards and take a look at them and be able to provide some insights as well.
Yes, I'll look into them, and I'll be available after the session in the extra chat. What was it?
Okay, it's there is actually just a couple of last questions because we're not quite at our time yet. So Jan asks, he says, this is really about trust. If you trust the system, you don't need explanation. Could we say that explanation enhances trust?
It enhances trust, definitely. I don't agree that you don't need the explanation when you trust the system, because the environment changes, and then you need to be sure whether the system adjusted in the right way. And so then you need the explanation again.
Well, and also Ulrich points out, and this was a point that I was going to raise, is that in this year's white paper on AI, the European Union has comments on unexplainable decisions. You can't really have unexplainable decisions because you don't know whether there's biases that are going to be there or not.
Exactly. And now I would like to remind the community that we have had the ability to create explainable rule-based systems for quite a long time. And we haven't done a very good job in doing that either. So there is a challenge here. And that's why I want to raise the awareness that it's just a small step extra for a lot of value.
Okay, great. Well, I think everybody's looking forward to continuing the discussion over on Slack. So thank you very much, Silvie. And if you'd like to unshare your screen, we can prepare for the next presentation.